Okay, so let's start with your questions. Sorry, I just didn't hear what you said. Forgive me. So today is the 9th. Yes. So the problem or problems. Where am I looking? 19 on a 180, 89. Okay. 180, 89, 187, 189. Problem 19. So y equals v cubed minus 2v, the square root of v divided by v. Of course, because the denominator, we had a similar situation. Because the denominator is just one term, I will definitely split it. I'm not going to spend time on this, right? And use the ratio rule? No, the quotient rule. So this is v squared. I simplify minus 2, the square root of v. And then I say y prime equals 2v minus 2, 1 over 2, the square root of v. Because I know when I differentiate the square root of v, I get 1 over 2, the square root of v. We know that, and it was established. And then I simplify, and y prime is 2v minus 1 over the square root of v. If you want to find the least common denominator, then you have 2v, the square root of v minus 1. This is what I would do for any situation in which the denominator is just one term. I would not mess with the quotient rule. You will get the same answer if you do, but it's a longer process. Anything else? Yes?
Next page, number 53.
Yes.
I think we did this last time, so I still have it.
53. On page 190?
Yes.
Okay. How many tangent lines to the curve y equals x over x plus 1 pass through the point 1, 2? At which points do these tangent lines touch the curve? Okay. So how many tangent lines to the curve such and such pass through the point 1, 2? What do I have to find first? So this is a graph, this is a curve, y, and I'm asked to find how many tangent lines to this curve pass through the point 1, 2. So here's the scenario. 1, 2 is this point. And let's say I know that this function has a horizontal asymptote. If you remember from pre-calculus, you can also graph it. It has a horizontal asymptote at 1. It has a vertical asymptote at -1. And now the graph of this, from the left-hand side of -1 with -0.9, negative and positive, so, and it crosses at 0, 0. And on the other side is the opposite. So there are possibly tangent lines to the curve of this function, y, that go through that point. Possibly even here. So these are tangent lines to the graph of the given curve or function. So what do I have to find? Yes, I have to find y prime. Here I have no choice. I have to use the quotient rule. Again, it's up to you, the way you like it. I will use my 1, 2, 1, 2. The first function prime is 1 times the second function minus the first function times the second function prime, which is 1, over x plus 1, everything squared. Any questions on differentiating the quotient? So these two go away. So then y prime equals 1 over x plus 1 squared. Okay? So I'm going to say that at a particular point, I'm going to call it P, x comma f of x, of course, right? I will determine the slope of the tangent line. I'm going to call this point A, of point PA, of line PA. How do I find the slope of the tangent line PA? What would you tell me to write? Yes. So this is 1 comma 2. Very, very good. So f of x minus 2 divided by x minus 1. And this has to equal, say it again. No, because if it's 0, then it means that the line is horizontal. If a slope is 0, it means that the line is horizontal. But it's not the case here. Sorry, Thomas.
Has to equal to 1 over x.
That's it. Right? So the slope of the tangent line must equal the derivative at this point. Must equal f prime of x. Because at this point, or any point, so if you want to ask me what is the derivative here, I'm going to say f prime of x for that point. If you're going to say what is the derivative here, I'm going to say f prime of x for that point. Good. So now I have an equation in which f of x is the original function. So I have to replace it here, in here. So I have x over x plus 1 minus 2 over x minus 1. Any questions on this? Any questions before we move on this problem?
Why don't we just plug in the x value into the derivative? Like
Yes, I have. Yes, I am. I'm plugging in x because I don't have it.
Right.
I cannot plug this in. This is a point somewhere. It's not a point on the function. Is that clear?
Yes.
I can only plug in this value, which I did, and I got f of x.
Okay.
But this point has nothing to do with the function. So if the point A were on the graph, then I would have said f of 1 must be 2. But it's somewhere in there. The function doesn't pass through it. That's why I graphed the function, to show that A has nothing to do with the function. Is that better?
Yes.
Okay. So then I have an equation to work on. F of x gets replaced. X over x plus 1 minus 2 over x minus 1 equals 1 over x plus 1 squared. How do I solve this equation? It's a very good problem, very interesting. So how do I solve this? What do I have to do first? What type of equation is it? The top. I have to find the least common denominator. Absolutely. Good. So how do I find the least common? What is the least common denominator of these two fractions? Of course. What do I need to multiply -2 by? Good. I know that not just Thomas knows this, right? Okay. So what will you tell me to write at the top? Agreed? Okay. So now I have a fraction on the left-hand side over another fraction. And I will combine like terms in a minute. So I have this over this. How do I address a fraction over another fraction? How do I divide a fraction by another? Right. So I have the top, which is -x minus 2 divided by x plus 1 times 1 over x minus 1 equals 1 over x plus 1 squared. So I had x minus 2x, which is negative x, and minus 2, and I copied x plus 1. I flipped the denominator. So now I will multiply. You could simplify both sides by x plus 1 at this point, but let's say we don't see that. Now this is a proportion. How do I solve a proportion? What do I have to do? And that works only in a proportion. Cross multiply. So I'm going to cross multiply. So I have negative x minus 2 times x plus 1 squared equals x plus 1 times x minus 1. Of course, I know that x cannot be negative 1. No question there. X cannot be negative 1. There's no such thing. Therefore, I can divide both sides by x plus 1. And of course, I also know that x cannot be 1. From here, both conditions have to be fulfilled. Okay, so now let's see what is left. I have this product to equal x minus 1. So I will distribute x to negative x, x to negative 2, 1 to negative x, and 1 to negative 2, and equals x minus 1. Now it changed into a quadratic equation. And I have negative x squared. This is negative 3x, and I bring another one, negative 4x. And this is positive 1. So negative x squared minus 2x, that's minus 3x. I subtract an x, and then I add 1. And of course, I will multiply both sides by negative 1. X squared plus 4x plus 1 equals 0. I could use my poly feature in my 86, but let's use the quadratic formula. Negative b plus or minus b squared minus 4ac divided by 2a, only because we want exact answers. So x equals negative 4 plus or minus, if you remember, the square root of 12 is 4 times 3, so it will be 2 the square root of 3 divided by 2. I will factor out the 2 and simplify, or separate the fraction, and the final answer is negative 2 plus or minus the square root of 3. So there are 2 points P, P1 and P2, one of them with negative 2 minus the square root of 3. Sorry, I rushed, and it's not clear here now. So I'm going to write this again. So it's negative 2 minus the square root of 3. And then the other one has an x that is negative 2 plus the square root of 3, and f of that number. So I have to wait for a second for it to dry out. So the function was x divided by, I think, was x plus 1, right, in the denominator. Right? Yes. Yes, x plus 1. X over x plus 1. So this will be negative 2 minus the square root of 3 over negative 2 minus the square root of 3 plus 1. And yes, I will have to rationalize, and I have negative 1 minus the square root of 3. I will factor a negative 1 from the top and negative 1 from the denominator, and they both become positive. And I should rationalize with this and get 3 minus 1, or 1 minus 3, I should say, negative 2 in the denominator. So this is 2 minus 2 the square root of 3 plus the square root of 3 and minus 3. So this is one value here that I'm trying to find. So this is negative 1 minus the square root of 3 over negative 2, or 1/2 plus the square root of 3 over 2. So this is 1/2 plus the square root of 3 over 2, and this was minus the square root of 3. In the same way, I determined the other one. So those are the 2 points. So coming back from my graph, so this one was negative, so this will be this point here somewhere, P2, P1, and this will be this point here. Any questions? Very good question. Yes?
Can I ask one about the course in general?
Yes.
Can we do more practices like this before the homework? Because I feel like I don't, like, in my case, like, I don't stand a chance against a problem like that without seeing anything.
There is so much I can do in class. So that's why I'm asking you to work on these problems, and that's why I'm more than happy to work on them. I will not be able to finish anything if I address each and every type of problem. But I'll be more than happy to when you, after you look at it and you say, well, this is not clear to me, then we'll go over it.
Got it. Okay, thank you.
With pleasure.
Can you go over 33 and 3.1?
Yes, 33 and 3.1. 33, 3.1. Find equation of the tangent line to the curve at a given point. So y equals the 4th root of x, or x to 1/4, and the point is 1, 1. Find the equation of the tangent line to the curve at the given point. So what do I have to find? So the equation of a tangent line will be y minus y1 equals the slope times x minus x1, where I have x1 and y1. What am I missing here? In order for me to determine the equation, I have to determine one more thing, which is the slope. How do I find the slope? Y prime. So the slope is y prime. So this will be 1/4 x to 1/4 minus 1, which is negative 3/4. But this has to be a number. How do I get that number? So I found the function that gives the slope of the tangent line at any point where this function is differentiable. But I need a specific slope. How do I find that specific slope?
Plug 1 in front.
Exactly, and that's what I'm going to do. X equals 1. X equals 1, so this is 1, so that will be 1/4. And can you take it from there? By writing y minus 1 equals 1/4 times x minus 1. Is that okay? Combining like terms, distributing, and then finding y. Rihanna, is that okay? Do you need more on this? No. Okay, perfect. Anything else that you worked on?
Can you do
Yes.
number 47 from page 190?
47 on page 190. Let's take a look. 47, 47. Yes, we did this together somewhat, but let's do it again, or similar. So we're given g of x, which is x times f of x. And we are told that f of 3 is 4. We are told that f prime of 3 is negative 2. Find the equation of the tangent line to the graph of g at the point where x is 3. So point with x equals 3 and some y. So find the equation of the tangent line to the graph of g at the point where x is 3. Okay, so what do I do?
Find the prime of gx.
Excellent. So g prime of x, how do I write this?
1 times f3.
Not yet. Not yet. I have to find the function first. Yes. The first function prime times the second function plus the first function times the second function prime. So first I have to write the function. Now I'm ready to plug in 3. F of 3 plus, excellent, times f prime of 3. And now let's see if we have these numbers. Do I have this? Plus 3. Do I have this? Negative 2. So 4 minus 6 is negative 2. So the slope at 3 is negative 2. So we're asked one more time, find an equation of the tangent line to the graph. So what I have right now, I have y minus y1 equals the slope times x minus x1. I have this, which is negative 2. I have x1, which is 3. What am I missing still? y1. So I'm missing this. So this is my y1. So now the question is, my y1 is nothing else but g of, yes, this is nothing else but g of 3. So let's find g of 3. So g of 3, which is my y1, is, g of 3 is 3 times f of 3. So 3 times f of 3. Do I have f of 3? 4. So then I have 3 multiplied by 4, which is 12. And I have my y1. Is that good enough? Good. Perfect. Anything else? Anything else? Yes, Tony?
I'm looking at the syllabus, I'm guessing we're not having a test on Wednesday?
No, of course not.
Okay. Sure.
No. I'm way behind. So my target is Wednesday, October the 25th
Okay.
for test 2. No, of course not. That was just a target date for you to have an idea about. So let's work on this for 3 minutes. And work on it and then finish up the rest. Hopefully we can make some headway with the other 2 sections. They may have thought that we don't have class today because of the Columbus Day, or where are we? Almost done? Is that a yes?
No.
Thank you. Thank you. Thank you. Okay, 1 more minute. We do not expand the denominator, ever. No, Charlie. Don't waste your time. We want the denominator factored. We're not going to expand the denominator, ever. Ever. Okay, unless you can think of anything like maybe it's a proportion and then it ends up in the other side and then we have to, but no, this is not an equation. So everything is perfect, but you don't have to expand. Okay, I still have to show it because one student made an error. Everyone else is on the right track. I'm happy to see that. So remember, it's 1 divided by 2 prime, and it's 1 prime times 2 minus 1 times 2 prime if you are using my method. If you reverse these two, it's a terrible mistake. Okay? So if you're using this sequence, then the top prime is 2x times the denominator minus the top times the denominator prime, which is 2x plus 1. Use the one you are used to, use the one you like. I don't really have a say in this. So I will distribute 2x cubed plus 2x squared plus 2x minus, I'll distribute from here or from, it doesn't matter. So minus 2x cubed plus 2x minus x squared and plus 1 over x squared plus x plus 1 squared. These two go away. And then I have indeed x squared plus 4x, and plus 1. So everyone did it correctly because you used the correct method of differentiating the quotient. Either you can write 2 times 1 prime minus 1 times 2 prime, or you can write 1 prime times 2 minus 2 prime times 1, whatever you want, but you cannot reverse these two. Okay? So that's perfect. Well done. Okay, so let's go back now to tell you where we are. So we are here still talking about this a little bit. I would like, if possible, to accomplish this today, if we can. And then I need probably about 2 weeks to finish this. This will not be long. This will not be long. This is very long because we have to work very on many issues, many different problems. And this is not long, and this is not long. But assuming I accomplish this today. So let's go back to, I know I just want to embed this in your bloodstream. So I want you to choose a topic to discuss for 3 minutes from chapter 2. It's the only way, it's just repetition. So we talked about the tangent and velocity problems, the limit of a function, in which we said we're going to prove this soon. We only proved it with a graph. And we discussed this in this section right now. One-sided limits. Then we talked about limit using limit laws, which is very important. Those two limits have to exist. If they don't exist, we cannot apply anything. This is the squeeze theorem, the precise definition of the limit, the epsilon delta definition for the finite limits and infinite limits. Okay, one more time, the definition of continuity at the point, limit from the left, the limit from the right must equal the function value at that point. Types of discontinuities, infinite, removable, and jump. Continuity from the right and from the left. A function is continuous from the right if it equals the function value at that point. It's continuous from the left if it equals the function value at that point. And we know that if a function is continuous at every point on an interval, it's continuous on the interval. If f and g are continuous functions, c is a constant. All these combinations of functions are also continuous. Any polynomial is continuous everywhere. Rational functions are continuous on their domain. Same with all the other functions. So now this is the theorem that I mentioned. I'm going to have to use it a lot in the next section, not 3.4 and 3.5, the next one, which says I'm allowed to swap operators under certain conditions of continuity, of existence, and so on and so forth. So the limit of the function of g is the function of the limit of g. So I pull this operator in front of the limit. And this is a very useful method, and I'll remind you when. So the intermediate value theorem. We learn how to make a function continuous everywhere if it has a removable discontinuity. How to determine different parameters to make it continuous everywhere. Okay, and we can review the rest next time. So I think my 3 minutes is up. Okay, so please remember, look at these every now and then, and this is everything in chapter 2. Okay, so coming back to okay. So let's go back to my okay, sorry about that. So here's where we are. Sorry to make you wait on this. Okay. So real quick, let me know if you have any questions on the last lecture. I should have written here that not just that it's not equal to 0, but also no solutions, which is the same thing. But then we looked at some derivatives and product rule and the quotient rule again. And we looked at that problem in which we graph the function and its derivative. And here we found parameters m and b that make this function continuous. And of course, we want it differentiable, but it had to be continuous first in order to make it differentiable. And that meant a unique tangent. And then we looked at another problem with a polynomial. We determined that polynomial. Then this was another function, and then this was a word problem. And then we went back to limits of sine and cosine. And I said, well, basically all I'm doing here are just algebraic manipulations. I'm not doing anything else. And this was a very important result, which is the Pythagorean theorem in a unit circle. Sine squared of an angle plus cosine squared of the angle of the same angle is 1. That's all algebraic manipulations, all in here. Okay, and then simplification. Any questions on what we covered last time? Anything? If not, we'll continue. I think we did everything, and we are in F. Am I correct? Okay, everything was done. Okay, so sine x minus 1, so we're asked to find the limit as x approaches 1 from either side, from sine x minus 1 over x squared plus x minus 2. Do we all have 3, the handout? Okay, perfect. So what do I do next? Well, I plug in 1 to see what type of limit this is. And when I plug in 1, what do I see? Of course, 0 by 0. I see at the top x minus 1 inside sine. And I remember this result that has to be in our minds always, where all these are equal. So what should the answer be here? 1. So when x approaches 1, can I say that x minus 1 approaches 0? Because if I can't, then I cannot use this result. When x approaches 1, does x minus 1 approach 0? Yes, I just subtracted 1 from both sides. Good, so I'm on the right track. Limit as x approaches 1, or if you want, x minus 1 approaches 0, from sine x minus 1. And I'm close, right? I have this, I'm hoping for this in here. What am I hoping for here? Right, I'm hoping for x minus 1. Since I got 0 in the denominator, there must be a factor of x minus 1 in there. There is no question about it. Otherwise, I would have not gotten 0. So now I'm asking you, what is the second factor here? Correct. So now this was only an algebraic manipulation to show that this approaches 1. So now all I have is 1 over x plus 2 as x approaches 1. So what is the final answer then right here? That's it. Excellent. Good. Okay, so now finally we got to the step in which we look at derivatives of functions, of trig functions. There are 6 trigonometric functions. I normally ask my students, which one would you like to prove? I like to prove either sine or cosine. And then using that, we can prove all the other ones. So please choose one proof, either sine or cosine. You want sine? Okay, so we are given the function f of x, and we want to find f prime. We do not know differentiation rules, meaning not rules, but we don't know the result. We only have, if we don't know the result, we only have one option. What is that option? Yes, you can say plug it in Maple, true. But by hand, what is the option? I'm ready. Exactly. Exactly. That's my only option. Yes, I can plug it in Maple, and I'm hoping that you looked at this, the command. It's diff and whatever function. Okay. But as I said, I'm not going to ask you to prove this, but I don't like telling my students, here, memorize this. At least you should see it once and how it works. It's not a difficult proof, but it's a little cumbersome. It's not very straightforward. Not difficult overall if you remember the rules, the trig identities, but it's not something to write home about. So limit, there's nothing I can do here, there is nothing I can do here, so obviously there must be something I can do here. So front cover or back cover of your book will show you how to, what is the identity for sine x plus h. You cannot say sine x plus sine h. There is no such thing. There is a specific identity, trig identity, that will replace sine of x plus h. And let me write it for you. Anyone remembers? Exactly. Sine A, cosine B, plus sine B, cosine A. Again, it's just a habit of keeping 1, 2, 1, 2, 1, 2, so I don't forget. But you can use the method you like. Good. So this is what I have to write that replaces sine x plus h. Sine x, cosine h, sine h, cosine x. So let's write that. Sine x, cosine h, plus sine h, cosine x, minus sine x divided by h. Okay, that was the first step, the first identity that we had to remember. Good. Next. I will have to look at these two and factor out what? Good. And I have cosine h minus 1 plus sine h cosine x divided by h. Now the question you can say, wait a minute, why did you choose that? First of all, there was nothing else I could do. These are the only terms that have something in common. Secondly, so I could not connect this term with any of the other two. There is no sine h anywhere. There is no cosine x anywhere. So this is my only chance to look at these two terms and say, oh, okay, they have a common factor. Okay. Then I have to remember what this equals to, or sort of. And here it is. Sine squared a equals 1 minus cosine a divided by 2. And you can say, wait a minute, how did you get to know that this is something close to this if you factor out -1? It's because it's the only chance I have. There is nothing I can do to this, there is nothing I can do to this, so that's my only hope, that I can do something here. So if I mimic this, first of all, I have to factor out -1, so I have 1 minus cosine, not cosine minus 1. That's one thing. And secondly, if I solve this equation for 1 minus cosine a, I will cross multiply. So 1 minus cosine a is twice sine squared a. So this is another identity from trig that I have to use. And this is sine squared of a equals 1 minus. So the formula is sine squared x over 2 equals 1 minus cosine x divided by 2. So it's a divided by 2 here. Okay. So, and also here, of course. So that's the identity. And I had to make it happen for h now. So I will factor out -1. That's my first step. Limit as h approaches 0. Negative outside, sine x, 1 minus cosine h minus, no, not minus, plus, sine h cosine x divided by h. And I'm getting it ready now. I am going to replace this quantity using this. So then I continue with limit h approaches 0, negative sine x multiplied by 2 sine squared h divided by 2 over h. I didn't finish here. I have to think for a second what to do with that. Any questions so far? Any questions? Okay. Now I'm going to look at sine h and do something with it, because I will still not be able to factor. So that's my target, to see what I can do to this to be able to factor it somehow. And there is another trig identity, which is sine a equals 2 sine a over 2 cosine a over 2. That's another trig identity that now I am forced to use on sine h. So sine h equals 2 sine h over 2 cosine h over 2 times cosine x. So plus 2 sine h over 2 cosine h over 2 times cosine x. We're getting close. Finally, I have two terms that have some common factors. So one more time, I used on sine h, 2 sine h over 2 cosine h over 2, and of course I had to copy cosine x. Okay, so now look at the terms at the top and tell me what would you factor out. So I continue here. Limit, say h approaches 0. Tell me what would you factor out. 2 times sine h over 2. Very good. Perfect. Let's see what is left. A negative sign is left. A sine x is left. And a sine h over 2 is left. Let's check one more time. 2 is out. 1 sine over h is sine h over 2 is here. A negative is in here. A sine x is in here, and one of those is here. Now plus 2 is out. Sine is out, and now I'm left with cosine h over 2 times cosine x. Any questions so far? Last identity that we need to use. Does anyone remember what does cosine h over 2 cosine x minus sine x sine h over 2 equal to? So let me write it here. Cosine A, cosine B minus sine A sine B. What does this equal to? Excellent. Cosine A plus B. Indeed. So all this gets changed into limit. So h approaches 0. 2 is outside. Sine h over 2 divided by h times. So cosine x, cosine h over 2 minus sine x, sine h over 2. So it will be, as you said, cosine. And what do I have in parentheses? Over 2. Excellent. Almost there. Almost there. One more step. One more algebraic manipulation. I'm just looking to see where I'm with time. 50. Okay, I have to finish. So let's stop it. Okay, very good. So now, would you agree that when h approaches 0, also h over 2 approaches 0? So I have the box, I have this box, but I don't have it here. No problem. Now I do. I multiplied and divided h by 2. This 2 will go away with this 2. Can anyone tell us where is this going? Box, box, box. Sign, box, box, box. Good. Can anyone tell us where is this going when h approaches 0? And then 0 over 2. And then what is left from this whole thing? Thank you. So after all this, what will you say to anyone, always from now on, that sine prime equals cosine?